Welcome. Ever wondered how the Linux allows you to create shortcuts or references to the files and dictionaries without duplicating them? In today's video, we'll unravel the mystery behind the hard links and symbolic links, two powerful tools for managing files in the Linux. Let's get started. What are the links in Linux? Links in the Linux are references or shortcuts to the files and dictionaries. Instead of duplicating the data, link allows you to access the same information from multiple locations. There are two main types of links. Hard links. It directs the references to the original file's metadata called inodes, and the next one is symbolic links, or often called as soft links. It has pointers to the file's path, much like shortcuts in Windows. Let's dive deeper into each of these. Hard links. The main question is, what is a hard link? Hard link is a direct reference to the inode of a file. Think of it as giving a single file multiple names. All these names share same data. In most simple words, having two or more names and a file can be accessed in multiple ways, but it is physically one. You can observe the same in the following picture. Assume this disk as a file system and this small disk as a file inside the file system. You can observe the file is physically one, having the same inode, but it can be accessed in a multiple ways, or it has the multiple names, file name 2 and the file name 1. This is called as a hard link. Here are some important features of hard links, or you may call it as a characteristics. A hard link shares the same inode as a original file. It's all because, as the definition said, a file with multiple names but a physically one, so it shares the same inode. Any changes to one file are reflected in all its hard links. We'll check it. We should not trust anyone without any proof. And the third point is, hard links cannot span across different file systems or partitions. It means all the original and its hard link should remain in one file system or a partition. We'll check this too. And the fourth point is, they are often used for file backups when storage space is limited, as deleting one link won't erase the actual data. This is a practical use of a hard link. However, hard links cannot be created for dictionaries, which avoids the potential loop in the file system. We'll check. We'll try to create the hard link for a directories and let's see what kind of error it receives. And here is the command we should use to create the hard link to a file. ln space, obviously, then the original file, which is also a source file which we want to create the hard link, and then followed by the name of the hard link. See, it's so simple. We'll practice all the things here what I said for hard links. First thing we need to do is we need to create a original file. Let me create original.txt. It's done. So you can observe here that file is created, and then let me put some information for our reference into this original file, like and so it's done. And let me cross check whether this information is present in this file or not. Yep, it is there. Now I'm going to create the hard link. So ln space and then the file name original.txt, and now it followed by the hard link name. You can see here in the desktop only the original file is present. So the hard link should be created by the command. When the hard link is already there prior to the command, it gives some error. So we'll see. I'll create hard link 1.txt. So you can see here the hard link 1.txt has been created. Let me do that again. When I press enter, it gives an error because the hard link 1.txt is already present in desktop. See, ln failed to create a hard link 1.txt because the file already exists. So it means the hard link should be created by the command. Prior to the command, if the file exists, it gives error. And we have created the hard link in the desktop folder. Let me create a hard link in a music folder. So hard link and the original may remain in the same file system in different dictionaries also. So ln original.txt and then the music folder music hard link to txt. It doesn't give any confirmation, so we need to check ls. So you can observe hard link 2.txt has been created. We're gonna check whether this hard link 2.txt carries the same information as the original. So see, the hard link and the original carries the same information, and as I said, it shares the same inode number. We'll check that. So I use ls.l. Oh, it doesn't give any inode number. Okay, I need to use I for inode. So you can see here, hardlink1.txt has 540169 as an inode number, and the original also has the same 540169. Let me check this hardlink.2.txt has also the same inode number. I don't think I need to give this file name also. See, the hardlink2.txt also carries the same inode number, and it proves that the hard link and the original carries the same inode number, means it's physically one, but it has different names and it can be accessed through different ways. So the second point is proved. And let me do some change. Let me do some change in the original one. So I implement echo, changing the information. So I'm changing the information in the hard link 1. So I will check whether this change has been implemented or not. Hard link 1. So the change has been implemented. Let me check whether this replicates in original also. Okay, I think I given a spelling mistake. You can see here the change has been reflected in the original and the hard link. Let me check whether this has been implemented in hard link 2. See, we have implemented a change in one hard link, but the change has been reflected in all the hard links and the original. As I said, the definition, it is physically one, but the different names. And we try to create a hard link for a directory, a folder. Let me do it. ln desktop. We'll try to create hard link for a folder, and then inside the music we'll try to create a hard link for directory. See, you may observe the error. Hard link is not allowed for a directory. It means we can't create a hard link for a folder. And the next thing is, as I said, the hard link and its original should remain in one file system. So I have mounted a different file system in MNT folder, MNT shared folder. So let me show it for you. MNT shared. So you can see here this is a different file system than this one, and I'll try to create a hard link for this original.txt inside this. So ln original.txt and then mnt shared slash hard link 3. This is third link, right? So 3. So it receives an error. It's saying failed to create a hard link, invalid cross device link. It means this is a different file system. And the next thing is you can check the number of hard links present to the original by using this ls dot hyphen ls hyphen og, then press enter. So you can see the hard link .txt has 3 hard links and the original.txt has also 3 hard links. It means these both are same, so it receives the same. The modified date is also same and everything will be same. It's just a physical file with a multiple names. So the hard link for the file is 3. If I create another one like touch, and again I'll check the links. So you can see this gimme.txt has no links, only one file exists in the file system, so it receives 1. This file has been exist in 3 different ways, so it contains 3. This is all about the hard link. So let me come here. When creating and using hard links, there are few more important points to remember. It might sound some silly, but we must remember this. The first point is the original file must exist before you issue the ln command. It sounds silly, right? So the source file must exist, like original.txt must exist before using the ln command. The second point is the second file listed in the ln command must not exist prior to issuing the command. As we discussed, the link file should not exist prior to the command. It has to be created by using the command. Even if the link file exists prior to the command, it receives an error. We have seen this. An original file and its hard link share the same inode number. We have seen the hard link and the original share the same inode number. That point is also proved. An original file and its hard link shares the same data. We have seen the original file and the hard links file has the same data. Even if we change any one of the hard links or the original, the changes will be reflected in all the files that are linked. An original file and its hard links can exist in different directories. We have seen we have created a different hard link in music folder and then in a desktop folder. This is also proved. And the last point is a original file and hard links must exist on the same file system. We have seen this. We have tried to create in a mnt.shared folder, which is a different file system. It receives an error. It's all because original file and the hard links must exist on the same file system, not on the different file system. A few points to remember about creating hard links. And the pro tip, if you want to see the link count of a file, we must employ the command ls space hyphen og command. We have seen this command. And the next one, symbolic links or a soft links. The main question is, what is a symbolic or a soft link? A symbolic link is a pointer to the file's path, not its inode. It's similar to the shortcut in Windows and even point to files or directories on a different file systems. In simple terms, a symbolic link is like a shortcut that points to the location of a file or a folder, similar to storing the path of that file or folder. Unlike a hard link, it doesn't share the same inode because it simply points to the file or folder. In the picture below, you can see the file 1 is a symbolic link for the file 2. Here are some key features or characteristics of symbolic links. The first point is the symbolic links can span file systems. Unlike the hard link belongs to single file system, symbolics can be in different file systems too. They can link to both files and directories. Hard links cannot do this, obviously. Third point is if the original file is deleted, the symbolic links become broken or dangling. We'll see this practically. We'll test this one. Soft links do not experience a link count increase. We can check by using this ls-og command. Symbolic links are highly versatile, but they don't share the same inode number as the original file. I think we have so many things to test practically. And here comes the command. This is the command we use to create the soft or symbolic links for a file or a folder. ln, the same command, then space, and we need to use the switch or an option -s, then followed by the original file and followed by the symbolic link. Yet so simple. Here we are again. We'll practice all the things we discussed in symbolic links. And now here, and I have to create a different original file because it will create a confusion with the hard link original and the soft link original. So I'll create original2.txt, and I will employ a different information in this original. So I use echo. What should I do? Like my video. I'm doing a little promotion here. Original2.txt. Why I'm always typing xtx? So let me check whether this one is present in the original2 or not. Original2.txt. Oh, I used a wrong spelling again. Yes, like my video. It is there. And now I'll create a symlink, a symbolic link for this original. Again, I'm going to commit another mistake. And symlink 1.txt. You can see this has been created. It's same like a hard link. The symlink also has to be created by the command. If the symlink has been exist prior the command, it rise as an error. So I'll implement the same. So you can see it shows file exist, and I'll create another one. As I said, hard links cannot be created for directories, but for symlinks we can create for directories. I'll create a folder which is original D. You can see the folder has been created, and I'll create a symlink for it. Link s original D, and then followed by the symlink D. So you can see symlink D has been created by using ln command, which is for directory, symlinks for directories. And I'll create the symlink for directories in the music folder. The symlinks can be created different folders and in different file systems too. So let me create this original D inside the music folder, music / Symlink D2. So it doesn't give any error, means it has been created. So ls music. You can see here Symlink D2, which is a symlink for the directory. So here we have a GUI version of this Linux, and we can observe between the symlinks and the original by using icons. What about the terminal? How to distinguish these symlinks? By using LSLA. So you can observe here the symlinks can be identified by using this arrow symbol. It points to the original file, because you can see the original D doesn't point to anything because it is a original folder. Original2.txt is also original file, so it doesn't point to anything. Symlink1.txt and symlink D are the same links, so it points to their originals. We can create the soft links for soft links. I'll show how we can do it. Symlink1.txt is a soft link, so I'll create symlink1.txt, not xt, symlink1.txt, and then symlink2.txt. See, the symlink2.txt points to symlink1.txt, and then symlink1 points original. Let me create a soft link for a different file systems like ls mnt shared. Here we have sample.txt. Let me show what is present in this sample.txt. Sample.txt. Oh, there are a lot of information for the sample.txt, and let me create a soft link for the sample.txt. Okay, there are a lot of information present in this sample.txt. Let me create a symlink for this. ln-mnt shared sample.txt, and then I'll create soft link for this one in the desktop symlink4.txt. So you can see symlink4.txt has been created. Before the topic, which is a hard link, we can't create a hard link for different file system. They have a file in different file system, but here we can create. The mnt shared sample.txt is in different file system. The desktop is also in different file system, but we are able to create a soft link for this. And let me show cat symlink4.txt. Wow, the symlink also holds the same data as the original. As I said before, the symlink and original doesn't share the same file or same data. But how this symlink 4 has the same data? It's all because the symlink4.txt will hold the pointer when we are viewing the symlink, or when we are editing the symlink. Actually, we are not viewing or editing the symlink. We are actually doing it in the original file. The symlink just holds the file path to that original. So when I do some changes, you can observe the changes will be directly implemented in the original, not in the symlink. The symlink just holds the pointer. That's it. So when I use ls la, so symlink 4, which is pointing to the sample.txt, which has the file size of 22. That's it. We have the file size of mnt/shared/sample.txt, which is 22. When I show this mnt shared slash sample.txt, so you can see the size of this sample.txt is actually 1000 bytes, but for the symlink, which is 22 bytes, just 22 bytes. For the, you can observe the hard link. Hard link, the original .txt is 25 bytes, and the hard link for the original .txt is also 25 bytes. If we made changes, the changes will be reflected in hard links also. But for the soft links, the soft link size is just 22 bytes, and the original one holds 1000 bytes. When we make some changes, it will be directly referring to the original, not for the symlink. Symlink just holds the pointer to that file path. That's all of it. Before, we have created a soft link for the soft link, and then the soft link to original. When I use LSLA, and then you can see here symlink 2 has been created by using symlink 1 as a reference, and then symlink 1 to the original 2. Here we have a chain, symlink 2 and then symlink 1, and then up we have original 2. What if we want to point out the original file without using this between symlinks? So we need to employ read link and then -f, and then we have to give the symlink 4.txt. Oh, wrong one. Symlink 4 has been pointing to the sample.txt. We need to give symlink 2, not 4. You can see here, actually the symlink 2.txt points to symlink 1, but symlink 1 points to original 2. When I use the read link /f, the symlink points to the original 2.txt. That's all about it. Here we are again. The symlinks are identified by an arrow in the ls/l output. We have seen this one, so no need to repeat it again. Few more points about the symlinks. We have proved all of these points. The original file must exist before you issue the ln-s command. We have seen this one. The second file listed in the ln-s command must not exist prior to the issuing the command. Same as a hard link, we have seen. The original file and soft link doesn't share the same inode number. We have seen this one too. The original and soft links do not share the same data. I have proved this one too. The original and soft link can exist in different directories. We have done. Original and soft links can exist in different file systems. We're done. To link a directory, we have seen how to link a directory's links in the soft links. So here is a pro tip. To trace the symbolic links, use read link -f command. It shows the final file path even if multiple links are chained. We have seen this one. Security warning. Be cautious with the symbolic links. If the original file is replaced with a malicious file, the symbolic link could be pointed to the posing a security risk. These often we called as a stale links. A stale link can be a serious security problem. A stale link sometimes also we call as a dead link also. When the soft link points to the file was deleted or moved, the soft link itself is not removed or updated. If the file with the original name and the location is created, now soft link points to a new file. If the malicious file put it in the original file's place, your server security could be compromised. Use symbolic links with caution and employ the unlink command if you need to remove a linked file. We'll see why we use this unlink and how it works in the next slides. Here are some differences between the hard and symbolic links. The feature, hard and symbolic links. The type of reference. Hard link points to the inode and symbolic links points to the file path. Span in different file systems. Hard link cannot span in different file systems, and the symbolic link can do that. Works on directories. Hard link cannot be done on directories, and symbolic links can be done on directories. So it's yes. Broken if deleted. If even we delete the original file, The hard link cannot be broken. It can continue. Symbolics cannot continue that. If the original file is deleted, the symbolic links will be broken. Here we can see how to delete or unlink the symbolic links and both the hard links. So let me do it here. The original.txt is a original for the hard link. Let me do unlink and then hard link 1.txt. So you can see hard link 1.txt has been removed or deleted. And then unlink symlink 1.txt. You can see symlink 1.txt has been removed. Actually, there is another command, alternative. We can use rm also, remove symlink 4.txt. This can also be done. Let me show if the original is deleted, how the hard link and soft links can react. So let me delete this original.txt, which is a original for a hard link. Hard link is located in music directory also, so remove. We can't use unlink for this one because it's a original. Unlink can be done only on link files, not on originals. So I have removed the original.txt. Let me check whether this one is there or not. Music slash. So you can see hardlink.txt is present. Let me check with the content. Hardlink2.txt. Oh, I have given a wrong one. I need to specify the complete path. You can see changing the information we have done in previous video, which is present. We have created the original for the hard link, but it cannot affect the hard link. So let me do the same for the soft link also. The original2.txt is a original for soft link, original2.txt. I have removed this one. Let me check this symlink.2 cat symlink2.txt. It is showing symlink2.txt is not present, but we have, even if we open broken link, you can see the broken link. Here we are again. To remove the links, we can use rm or the unlink. Rm can be done on originals and the links, but unlink can be done only on links, not on originals. So if you want to see the inode number, we use ls-i. We have seen this one. For the practical cases where we use the hard links and the symbolic links, use the hard links for redundancy, such as backup systems where we need to keep the data safe even if the original data is deleted. We have seen the original data is deleted, but still the hard link works. Use the symbolic links for convenience, like creating shortcuts for organizing directories across the file systems. We are done with this, I think. And now we are here for the practical questionnaire. The question 1. You have a file name as report.txt in your current directory. Create a hard link to this file named report-link. What command do you use? Yes, you are correct. The correct answer is A. ln report.txt and then report link. Here goes the next question. Question 2. Which of the following is a key difference between the hard link and symbolic link? I'll wait for a few more seconds before revealing the answer. Yes, you are correct. The answer is B. Hard link reference to the inode of the original file, symbolic links reference the file name. And here goes the third question. You create a symbolic link to your file using the following command. Later, the original file is deleted. What happens when you try to access this symbolic link? I'll again wait for 5 seconds before revealing the answer. Yes, you are correct. The symbolic link points to the non-existing file, results a broken link. Question number 4. You need to create a symbolic link named as my directory link for directory called projects located in home/user. Which command you use? Again, 5 seconds before revealing the answer. Yes, you are correct. The answer is B. We'll employ the symbolic links. The final question in this video. After creating a hard link to your file, you notice the file link count increased from 1 to 2. What happens if you delete the original file? I'll again wait for 5 seconds before revealing the answer. Yes, you are correct. The answer is B. Hard link still works, file data remains intact. That's it for today's tutorial on Linux links. Whether you are creating backups or organizing your files, understanding hard and symbolic links will save your time and effort. If you find this video helpful, give it a thumbs up and subscribe for more Linux tips and drop a comment below your questions and suggestions. See you in the next video.